Hello, beautiful brains. Welcome to the Castle of Maths Fanatics. So today we're going to be looking at 2019 Paper 1 KwaZulu-Natal Preliminary Examination. Okay, so in front of us here we have question 7 on a log function, right? Remember guys, a log function always goes with an exponential function. They are inverses of one another. Okay, so let me get my pen quickly. Okay, perfect. So use this color. Okay, awesome. So ladies and gents, here I advise you never to use this function when it's in this form. I'll show you a strategy that I use always for a log and an exponential function. It's a table method. But before we do that, we need to set up our equations first, right? So remember, g of x is basically y, right? So here I have y equals to log 5x. Then we're going to use the cross method to change it to the exponential form. So this is the log form. Its exponential form will be this. 5 is the base, so you write it as the base. And then we do the cross. This one comes there, and then that one goes there, right? So basically, we're going to have this x coming here, which is x equals to 5. The 5 coming, the y will come to the exponent there, right? Perfect. So this form and that form is the same thing, but this is the log form, this is the exponential form. So it's always easy to work with the exponential form, okay? Perfect. So now I'm gonna do the inverse of g. The inverse of g is gonna be y. Remember, to do the inverse, you just switch x and y, right? So I'm gonna, where I see x, I put y, where I see y, I'm gonna put x. Okay, so now this is my, okay, let's do this. So I have the table method, it's log function here. And then I have my table. This side I'm going to have exponential function. The table method will help you to answer as many questions as possible. I'll just answer as many questions as possible now, even when some of them are not here. Okay, so now what you do is this, right? Remember, your log function is x equals to what? 5 to the power y. And then your exponential function is y equals to 5 to the power of x. Awesome. And then now we're gonna find, okay, the asymptotes, right? We're gonna find x int, right? We're gonna find y int, right? We're gonna find domain. Okay. We're gonna find a range. Okay. These are the 5 basic things that you can get from the table, right? Yeah, remember, it's always easier to work from the exponential side, right? So remember, the exponential function, its asymptote is y equals to 0 because the asymptote is q. So if there's nothing here, it means we're just adding a 0. Does make sense? So this will be our asymptote for this part. Awesome. Okay. Marvelous. So now we're gonna go to x-intercept. Okay. X-intercept, we're gonna make y 0, right? So obviously, this graph does not have x-intercept, right? Because if I make y 0 here, let's see, 0 equals to 5 to the power x. But this will never be true. Does make sense? Sharp. Perfect. And then let's try y-intercept. For y-intercept, we make what? We make x 0, right? So here, you're just gonna write no solution, sorry. Write no solution here. Okay. And then now, remember for y-intercept, we make x 0. So I'm gonna go to my function and say y equals to, let's see, y equals to 5 to the power 0, which is 1. But because it's an intercept, we need to write it in point form. So I'll just do it here. Ne? Okay, let's do this. We'll say our x is 0, then our y is 1. That is our intercept. Okay. Then domain for the exponential is always x element real. Ne? Always for the exponential. It's x elements of real numbers. Okay. And then now I'll show you something. Ne? We always switch. The y asymptote is becoming the x asymptote here. That makes sense. Perfect. And then your x-intercept becomes your y-intercept. So my x-intercept will come here. So I'll have what? I'll have 0 equals to 5 to the power y, right? Which is no solution. So y-intercept does not exist at this side, right? And it makes sense because if you check on the y-axis, which is line x equals to 0, we have the asymptote, so we're not gonna touch it. That makes sense. Perfect. Then your y-intercept, this side becomes your x-intercept. You're just gonna switch that point there. Your x-intercept will be 1 and 0, right? So because I have the log function here, I already know that this point here is what? It's 1 coordinate 0, which is my x-intercept, right? Then my domain here becomes my range then. You check y elements of real numbers. You just switch the x and y, remember, right? Remember, range is y values, okay? And then now we're left with just doing the domain, okay? The domain, usually I advise you to interpret from the graph, né? The drawn sketch. If you don't have a sketch, just quickly sketch it for yourself, okay? Perfect. So domain and range, I'm going to always just interpret them from a sketch, okay? Perfect. So now let's see. So the domain, I'm gonna do the domain for the log function because this is what is given. I can see that this graph starts from x equals to 0 and keep on going to positive infinity, but it does not touch this line, right? Because this line, remember, the y-axis is the asymptote. So the domain, we're just gonna say x is what? Is greater than 0, right? Because you can see here that this graph exists only this part. Going to going to infinity, you see? So it starts here, but without touching here, and keep on going there. Sharp. Whatever my domain is on the log becomes my range on the exponential. So they are opposites. Ne? So you need to practice the what? The table method. As I said, the domain for the log and the range for the exponential. Ne? The domain for the log and the range for the exponential. Always use the graph. Ne? Use the graph. Perfect. Now let's answer the following questions, right? Let's answer the following questions. Perfect. Oh, sorry. Let's do this. Okay, write down the equation of the inverse in form of y. You already did there, which is 5 to the power x, right? Write down the range of the inverse. The inverse, remember, is the exponential, right? So the inverse is the exponential. So they want what the range, it's y is greater than 0. Do you see it? Y is greater than 0. Right. Then you score yourself 3 marks there. Awesome. And then to do the last question now. Okay, let me see all the drawings here. I'll show you how to do the last question. It's very easy. It's 3 marks. You always have to do it. Ladies and gents, if you have an inequality sign and you're doing a log or an exponential function, it is always advisable to do what? To do a rough sketch of the situation. Do the rough sketch of the situation. Awesome. So here basically, remember my g function was 5 to the power y equals 2x. The reason I'm writing this is because I'm seeing g there. Perfect. So I'm going to sketch this graph. Ne? I'm going to sketch this graph. Sharp. A. Oh, actually, my mistake. The graph is already sketched, right? So if the graph is already sketched, then I'm sorted. I just need to find, remember this is a y value, right? They need a y value that is what? That is less than or equals to -4. So what we're going to do, we'll just substitute -4 there. Okay. So I have 5 to the -4 equals to x. Then x equals to, let's check on our calculator quickly. Okay, my calculator, let's check. So we need 5 to the exponent of -4, which is 1 over 625. Okay, so we have 1 over 625, right? So remember this point here was 1, coordinate is 0. And then now, when y is -4, so I'm just going to approximate it. Let's say -4 is here. Let's say my x value here, right? My x value there is 1 over 625. Then what you're going to do, guys, you always draw this. No? You draw dotted lines going up. And then you draw dotted lines going there through your points. No? Yeah. So my solution is either going to be here or there. They're going to be in these two either here between 0 and this number. Remember this line here, it's x equals to 0, right? My solution is either going to be here or there. Now let's check which one. They need where this is. Remember, less than means below, right? Less than means below. So we're looking where this is below this value. Does it make sense? Which is here. Remember, this graph here is above this number, but here it's below, right? So what we're gonna do is, we've seen that it's from where? It's from x equals to 0 to there. So I know that 0 must be this side and 1 over 625 must be that side, because we always move from left to right. No? Okay, and then if it's in between, our inequality signs are always going to be this way. No? Sharp. But now, because here I have or equals to, you see this part at the bottom, or equals to, I'm only going to put it on this one, né? Not on this one. Why? Because remember, line x equals to 0 is the asymptote. It means we'll never have x equals to 0 for this function. So you don't have to put or equals to on the asymptotes. This is an important thing to note. Always when you have asymptotes and you're working with inequalities, they never take or equal sign. They only take greater than or less than. Makes sense? I hope this was helpful. And please kindly hit the subscription button and share with other maths fanatics. And also feel free to leave a comment. Thank you.